Hi grade 9s. Today we're going to go over insulators and conductors and methods of charging. And so we've already talked a little bit about insulators and conductors, but we're going to talk about it a little more thoroughly here. So this will be lesson 4.3. So you're going to need to copy down these notes in your notebook that I gave you, the package of notes. So this is the electricity one, and I think it's labeled as lesson 4.3 for you. Okay, so insulators. The charge that is produced on insulators does not travel anywhere. So this is what you need to copy down there in that blank. So it does not travel anywhere, but it remains in the spot where it is produced. So I want you to, in that little box there, I want you to sketch this diagram here. So I want you to sketch a person, and then you've got the balloon. So if you try this yourself, if you've got a balloon and you rub it against your hair, you end up getting static electricity. And so you're actually charging the balloon, and the balloon is an insulator there. So you're ripping electrons off from your hair and depositing them on the balloon, okay? So that is an insulator. Now, examples of that: glass, plastic, rubber, these are all insulators. Now, the question, can you hold an insulator without its losing its charge? And the answer to that one is yes, you can. If you hold a balloon, so if you've got a balloon, let's draw a balloon here. Mine looks more like, yeah. Anyways, so let's say we've got a bunch of negative charges all kind of together here, and then the rest of the balloon. I swear I start coughing as soon as I do these videos. Okay, so you've got this balloon where you've got this negative charged area there. Now when you have that, if you were to hold the balloon, let's say we've got a blue hand. If you are to hold the balloon here, is it going to remain charged? Yes, it will, because you haven't touched this area. Now, what if you bring your hand over and you rub your hand all over this area? Is it still going to be charged then? No, then it wouldn't be. Then you'd be grounding it, which we'll talk more about later. But as long as you hold an insulator from an area that's not where the charge is, it still remains charged. Okay, now we've got a conductor. So a conductor is when the charge moves around the entire object. So the whole object becomes charged. So it doesn't stay in one spot, it moves around here. So examples you can write down here are the metals, people, we're actually conductors too, water, and then in that box I want you to draw these two diagrams here. So a conductor, we see the charge moving around the whole metal ball here. Now, if this were made of rubber, like a balloon or plastic, you would see the charge only in one area. So a conductor moves around the whole object, non-conductor stays in one area. Now, we've got methods of charging here. So methods of charging. So number one, the first type of charging method that we're going to go through is friction. So this is when we just rub two materials together. The negative particles are stripped off of one object and are going to cling to the other object. So you can sketch this diagram here. So if you have a glass rod, for example, and you rub it with a silk cloth, you end up ripping off electrons from that glass rod and leaving that glass rod positively charged because you've taken the electrons away, okay? So that's how that works. Now, we're going to go through, I'm going to show you an example. This is a fun, hold on. I think I got to take this off. Hold on. There we go. All right. Oh my God. Okay, so this is called John Travoltage. So some of you may recognize John Travolta. He's like old. He's from like the 70s. So this was a disco dancer. Anyways, if we take his foot and we rub it on the carpet. Now, some of you have had this experience, right? If you rub your feet, if you're wearing socks and you scramble and rub across a carpet, what ends up happening? You get little shocks, right? You get static built up. So I'm going to get some static here. Now, this static, so now he's charged, right? So he's got electrons, an extra set of extra electrons running all through his body. Now, they just kind of sit there until he's able to discharge them. So watch what happens when he touches the metal door handle. And he gets a shock. This is like weirdly fun. And then if we leave it there, yeah, weirdly fun. Anyways, Google this. It's a super fun animation to do. John Travoltage. Just look up that. Anyways, so when we did that, he was getting electrons, and he was charging himself by friction, right? So rubbing his feet on the floor, on the carpet there. Now, we have another method of charging, which is called conduction. So conduction, aka contact. So conduction means touching. Oops. Oh, I forgot my thing. Hold on. There we go. Means touching. So touching a charged object to a neutral object. So this is what we went through the other day too with the pith ball. So this is an example here. You can actually sketch this diagram. That's kind of what we did with the pith ball here. So when we have a neutral object and we touch it with something that's charged, a charge transfer takes place. So there's electrons or negatives that are moving from one object to another, okay? So that's conduction. So we have friction here and we've got conduction. Those are the two ways of charging. We've got a third one called induction. So induction is when a charged object produces a charge in another object without touching it. So it's not touching it, it's just being near it. It can be temporary or permanent if grounded first. So you can write those words down. Now, I've got a demo for you. So it's the meter stick demo, and I will do that on the meet that is happening next. So I'll do that for you, and I want you to write down there what's happening. And you can do that there. It's pretty cool, so it's kind of fun to do. And then when you guys come back to class, you can also go ahead and do that as well. I'll let you try it because it's super fun. Okay, grounding is our next thing here. So when we ground something, what we're doing is we're connecting something via a conductor, so with a conductor, to the earth. So people can ground things because we are conductors. So the electrons are either going to leave or enter an object by connecting something to the earth, and that's why we call it ground, because you're literally connecting it to the earth, to the ground. This is a diagram here. You can sketch something here. Now, the Earth is a huge reservoir of positive and negative charges. So there is a lot of positives and negatives going on, which is why we can ground things, and the Earth is big enough that it can handle it. So anytime that we connect something to the Earth, we are discharging the charge, or the object is discharged or grounded. Okay, so that's just connecting it to the Earth to get rid of the charge. Okay, the assignment, you've already looked at this. This was the John Travoltage thing. Page 219, 1 to 9. I think you've already done 5 and 7, right? I think so. So you don't need to do 5 and 7, but you can do the other questions, and we will correct those together in the meet. Okay, thanks everyone.